Hi students, this is Balkishan, lecturer in chemistry, Government Degree College, Siddipet. Today topic, continuation of last video, crossed Aldol condensation. The definition of crossed Aldol condensation is Aldol condensation between two different aldehydes or ketones or one aldehyde plus one ketone is called crossed Aldol condensation. Crossed Aldol condensation. Okay, in this reaction, two or more products are obtained. Products are obtained. Products are obtained. For example, example 1, I am taking one molecule of acetaldehyde and second molecule of acetone. This is the second molecule of acetone. We obtain the 1, 2, 3, 4 different products. Here I am telling this is the first molecule, this is the second molecule. There is a choice 1 plus 1 combination. 1 plus 1 combination CH3, CHOH and CH2CH1. This is the aldol product. This is the aldol product. Here one and another one. How it is? CH3, CH double bond O plus CH2, CH1. By this shifting of hydrogen towards the oxygen, CH3, CH, here OH, and new bond with this one. CH3, CH, new bond with CH2, and H is OH. Okay. Another one, 2 plus 2 combination. 2 plus 2 means this is the acetone only. And CH2, H, C double bond O, CH3. In this one, the bond shifted to this side and hydrogen added to this side and a new bond with this one. This is the CH3 and CH3, COH, OH, CH2, C double bond O, C. This is the 2 plus 2 product. Okay, this is called, this is also aldol product, not the crossed aldol product. Now, in the second way, that is one of this molecule, that is CH3, C double bond OH, plus and the second molecule of this one. So this part is called as crossed aldol condensation. The aldol condensation between two different molecules and that is one aldehyde. So this is the one aldehyde and one ketone. This is the one ketone. Okay. Now the bond shifted to this side and this one added to this side. Hydrogen added to oxygen, carbon, new bond with this one. Now the product is this one. CH3 already present, CH already present. Now double bond converted in single bond and O bonded with hydrogen, new bond with carbon to carbon, CH2. After that one C double bond O, CH3. CH3, CH, OH, new bond with CH2, C double bond O, CH3. So this is the crossed aldol product. Crossed aldol product. Crossed aldol product. One more possibility Andy is that now here this is 1 plus 2 1. First molecule of acetaldehyde, second molecule of acetone. Another way 2 plus 1 is also possible. 2 is this one. This is the 2 here. CH3 and CH3 C double bond O is the 2 only. This is the 2. Here this is the 1. 1 is the CH2 H and CH bond. Now this bond shifted to this side and hydrogen added to oxygen. There is a new bond with carbon to carbon. Now the structure is CH3 and CH3. CH3, CH3, COH. Here C, single bond OH by the adding of this hydrogen. New bond with carbon to carbon. This is the CH2 and CH4. So this is also crossed aldol product. Crossed aldol product. This is okay. Crossed aldol product are totally 4 products are obtained in this case only. Here these 2 are the aldol products, remaining 2 are the crossed aldol products. That's why again definition of crossed aldol condensation and aldol condensation between 2 different aldehydes or we can take one is the acetaldehyde, other one is the propanaldehyde. Also there is a possibility of 4 different products. Okay, acetaldehyde, propanaldehyde. There is 2 different aldehydes or 2 ketones. One is the butanone or acetone. These 2 different aldehydes, ketones, and one aldehyde and one ketone. I am taking this example. One aldehyde molecule, other one is the ketone molecule. By the adding of acetaldehyde will give this one. Beta hydroxy, butyraldehyde. Already we learned in the previous video only. And acetone plus acetone will give that is this beta hydroxy methyl 2 butanone. Okay, anyway, that is also aldol product. Now this acetaldehyde one molecule can react with one molecule of acetone. We are taking so many number of molecules in the reaction vessel. That's why we are adding 1 plus 1. This means here we are taking how many molecules and 1, 1, 1. Totally 3 moles. Okay, here 3 moles, here also 3 moles. 3 in this 3 moles, 1 mole plus 1 mole is giving that one. And 1 mole plus totally 1 plus 2, that's 4 moles are required. Here 4 moles, this is also 4 moles. In this 4 moles, 1 plus 1 is giving this product. And 1 plus 1, 1 mole of this acetone, 1 mole of this acetone is giving this one. And 1 mole of acetaldehyde and 1 mole of acetone is giving this crossed aldol product. in the after completion of 3 moles and remaining 1 mole of acetone and 1 mole of acetaldehyde to combine to form this one. So this is called as crossed aldol condensation. Again, listen carefully. Aldol condensation between two different aldehydes or ketones or one aldehyde molecule, one ketone molecule is called as crossed aldol condensation. In this reaction, two or more products are obtained. This is the two only here different. Two or more products are obtained. One more example for the crossed aldol condensation. One more example. So this is the benzoyl. This is the acetaldehyde. In the presence of dilute NaOH. Dilute NaOH. This is also crossed aldol condensation. Here very important factor. This let I am first molecule. This is the second molecule. 1 plus 1 does not involve in aldol condensation. Does not involve in the aldol condensation due to the absence of alpha hydrogens. There is no alpha hydrogen and that's why this does not involve in the aldol condensation. Okay, 2 plus 2 involved in the aldol condensation. Already we seen CHOH and CH2CH1. This is the 2 plus 2. That's 2 plus 2 means CH3, CH double bond O and plus CH2, H, CH1. By the shifting of this one, this bond added to hydrogen. Now new bond with this one then CH3, CH, OH and their new bond CH, CH2, CH1. So this is aldol product. This is aldol product and not the crossed aldol. One molecule of acetaldehyde, other molecule of acetaldehyde combines to form aldol product. But there is a choice. This is another possibility. Here 2 plus 2 and already I say this one is not possible. Why? Because there is no alpha hydrogens. But there is a possibility and this is possibility. CH double bond O and this one CH2 H CH1. By shifting of this one towards the oxygen, hydrogen shifted to this side and this one is added to this side. Okay, so this is called 1 plus 2 additional. 1 of benzoyl, 2 of acetaldehyde will give only. So this is the product. Benzoyl and CH, OH and CH2, CH1. This one. When it is heated one water molecule from here OH, here one H eliminated as a water molecule to obtain this one. Here CH double bond CH, CH1. This is known as cinnamaldehyde. Cinnamaldehyde or alpha beta unsaturated aldehyde. Aromatic aldehyde or unsaturated aldehyde. So this is called crossed aldol condensation. The aldol condensation between two different aldehydes or two different ketones, or one molecule of aldehyde, other molecule of ketone, will obtain different products, and in the presence of dilute base like dilute NaOH or KOH is called as crossed aldol condensation. After this one next one is very important reaction is Cannizaro reaction. Cannizaro reaction. This is the very important reaction. Cannizaro reaction. Cannizaro reaction. I am taking this one. HCH only. There is no alpha hydrogens only. Formaldehyde, no alpha hydrogens. Two molecules only. In the presence of concentrate base only. That is concentrate NaOH. Already in dilute NaOH only it is a catalyst in case of aldol condensation but it is the reactant in Cannizaro reaction. This is the concentrate NaOH. To form this one HCOONA plus CH3OH. This is called as sodium formate. Sodium formate. This is the methyl alcohol. Now this is aldehyde. In general, this is the sodium salt of carboxylic acid. Sodium salt of carboxylic acid. This is the alcohol. Now the statement of Cannizaro reaction. The aldehyde or ketone. Ketone which absent alpha hydrogens. This is the very important one. Which present alpha hydrogen is the property of aldol condensation. Which absent alpha hydrogen is the property of Cannizaro reaction. That means the aldehyde or ketone which contains alpha hydrogens involved in the aldol condensation reaction. The aldehyde or ketone which absent alpha hydrogens can involved in the Cannizaro reaction. Okay. Now the aldehyde or ketone which absent alpha hydrogens reacts two molecules with concentrate base like NaOH or KOH to form mixture of sodium salt of carboxylic acid and alcohol. It is called Cannizaro reaction. Cannizaro reaction. One more important thing and it is a self oxidation and reduction reaction. Self oxidation and reduction reaction. What means only oxidation reduction? Here aldehyde to sodium salt of carboxylic acid is called as oxidation. Why? Because here only one oxygen, here one more oxygen is increasing. Adding of oxygen is the oxidation. And this aldehyde to alcohol and is a reduction. Aldehyde to alcohol is a reduction. Why? Because here only 2 hydrogens are present. Here 4 hydrogens are present. That means addition of hydrogen is a reduction. Only the formaldehyde is involved in the oxidation and are also involved in the reduction. That type of reaction is called as self-oxidation reduction. Only one molecule and that's aldehyde, that's formaldehyde, is converting into the salt of carboxylic acid and as well as alcohol. That's why this type of reaction is called as oxidation and self-oxidation reduction reaction. In this reaction one molecule of aldehyde or ketone oxidizes into salt of carboxylic acid. Salt of carboxylic acid and second molecule of aldehyde or ketone reduces into alcohol. This is the information about the Cannizaro reaction. See carefully, the aldehyde or ketone which absent alpha hydrogen, that's a very important point, and here which absent alpha hydrogens reacts two molecules with concentrated base like NaOH or KOH to form mixture of salt of carboxylic acid and alcohol. This reaction is called as Cannizaro reaction. Cannizaro reaction is the self-oxidation reaction. In this reaction, one molecule of aldehyde or ketone oxidizes into the salt of carboxylic acid and second molecule of aldehyde reduces into the alcohol. Here one more important and maximum cases only aldehydes are involved in the Cannizaro reaction. Because aldehydes are easily involved in the oxidation as well as reduction. But ketones are easily involved in the reduction but in special conditions involved in the oxidation. That's why in the examples we can take only aldehydes as the example for the Cannizaro reaction. Some cases ketones also involved and that is the different phenomena. Now I am taking mechanism of this reaction and so this is the statement and important points about the Cannizaro reaction. After this one, what is the mechanism? Yeah. Mechanism for this reaction. In this case, this is the first example. Mechanism step 1 Step 1, attack of nucleophile. Nucleophile. Here nucleophile is OH minus. How it is obtained? NaOH is giving Na plus and OH minus. This OH minus is the nucleophile. Okay. Now here first molecule of this one this is the formaldehyde HCHO. First molecule. First attach the nucleophile OH minus this bond shifted to this side and oxygen gets negative charge, carbon gets positive charge. The positively charged carbon attracts the negatively charged OH minus. It is a nucleophile there is a new bond with carbon to OH. And this one H already present, here O minus by the shifting of pi bond towards the oxygen. Oxygen gets negative charge and carbon gets positive charge. The positively charged carbon is bonded with OH and one hydrogen is present. So this is the transition product okay, intermediate product. Now step 2 this is the important step transfer of hydride ion. Hydride ion H minus. Transfer of hydride ion. Here H already present, O minus already present, H already present, OH already present. This is the intermediate product in the first step Now the second one, this is the second molecule of formaldehyde. HCHO, this is the second molecule. At this stage here what happens this bond shifted to this side now there is a double bond between carbon to oxygen. That's why this H minus bond shifted to this side, H minus is shifted from here to here by the shifting of this one. Here it shifted towards the oxygen, oxygen gets negative charge and here carbon gets positive charge. The positively charged carbon now attracts the hydride ion. It is also nucleophilic addition. First molecule involved in the nucleophilic addition, here nucleophile is the OH minus. Second step here also it is the nucleophilic addition, here nucleophile is the H minus and hydride ion. This is the specialty of this reaction. Both steps are the nucleophilic addition steps. In first one we are supplying nucleophile in second step the spontaneously hydride ion is transferring from intermediate product to the second molecule of the formaldehyde. At that stage H already present, here C, now new double bond and OH and plus HCO minus H already present, the bond shifted to this side, oxygen have negative charge, now new bond with hydrogen, this one. I am simply this is writing HCOOH and this one CH3O minus CH3O minus. Now third step step 3, transfer of proton. Here H plus called as proton. Here HCOOH is acid called as formic acid. Now CH3O minus methoxy group this is the base. Why it is base I will explain at this corner CH3OH, this is the alcohol. When this one releases H plus ion it becomes as a methoxy ion. methoxy ion. This is the acid and it is by the loss of one proton became as a methoxy ion. The acid base pair and which have one proton difference is called as conjugate acid base pairs. Called as conjugate acid base pairs. Here this is the acid means this conjugate base. Here this acid is the weak acid. Methyl alcohol is very weak acid. That's why methoxy ion is the strong base. That's why the strong base attracts the H plus ion from the formic acid to form the HCOO minus and CH3OH. So this is the one product and already here present. This is the product. Now HCOO minus and already Na plus is present at this position. Already this OH is reacted and so this is Na plus ion attracts to form HCOO Na. So this is the HCOO Na. Okay, this is the mechanism and formaldehyde reacts with concentrate NaOH to form sodium salt of carboxylic acid, sodium formate, and alcohol, that is methyl alcohol. This is the example for the Cannizaro reaction. In Cannizaro reaction, three steps are takes place in mechanism. First step is the attack of nucleophile. Here nucleophile is the OH minus and the OH minus attacks the formaldehyde. If there is no alpha hydrogen, directly it involved in the OH minus ion. If here alpha hydrogen is present and it undergoes according to the Aldol condensation, it converts in the carbene ion. That's why the compulsory condition in the Cannizaro reaction is has no alpha hydrogens. The aldehyde has no alpha hydrogens. Aldehyde must upset the alpha hydrogens. Okay, that's why here this OH minus attacks the carbon to form intermediate and this intermediate reacts with second molecule and by the transfer of hydroide ion and this is the special step and in this one the O minus shifted to this side and the bond shifted towards the hydrogen. That's why hydrogen H minus from here H minus is transferring and H minus is transferring to this side. Here carbon is plus and this bond shifted towards this one. Oxygen is the minus and this is the oxygen minus and hydrogen is added to this one. This is the methoxy group and this is the formic acid and the formaldehyde here converted into the formic acid and second molecule reduced with the methoxy ion. Okay, taking off hydrogen is the reduction and here taking off oxygen is the oxidation. That's why here oxidation formic acid convert in the reduction low alcohol convert. Finally and the acid is the formic acid and the methoxy is the base and the base is the strong base. That's why it attracts the H plus ion from the formic acid. That's why it becomes the methyl alcohol or alcohol and here the carboxylate ion, that's formate ion, takes the Na plus ion which present on the base and in the base and the Na plus reacts to form sodium salt of carboxylic acid, that sodium formate. And this is the first example and I am taking one more example and instead of this one hydrogen I am taking benzaldehyde. This second example benzaldehyde. This is the benzaldehyde in mechanism and I am changing only one hydrogen as the phenyl group and this is the benzaldehyde. Benzaldehyde reacts with this one and here one hydrogen is replaced by phenyl group and we obtain intermediate product. And this intermediate product and reacts with second molecule and here also two molecules we are taking and with second molecule. This is the second molecule. Here benzene ring, benzene ring, benzaldehyde అండి. Now here one hydrogen is replacing by this one. Here another hydrogen is replaced by phenyl group. Okay. Now finally అండి, this is the benzoic acid. Benzoic acid. This is the alkoxy అండి. Okay. Now finally this benzoic acid okay. This is the products. I am changing this hydrogen అండి with phenyl group అండి. Here also phenyl group CH2OH. This is called as sodium benzoate అండి. Sodium benzoate. This is called as benzyl alcohol. Here also no alpha hydrogens. In benzaldehyde, and this is the benzaldehyde. Here benzaldehyde, 2 molecules of benzaldehyde, and 2 molecules of benzaldehyde reacts with concentrate NaOH to form mixture of sodium benzoate and benzyl alcohol. The mechanism is similar to that one only. Okay. First step only, attack of nucleophile. Nucleophile is the OH minus, attacks the benzaldehyde to forming intermediate product, and this intermediate product reacting with second molecule of benzaldehyde forming benzoic acid and alkoxy group. And this alkoxy group is the strong base and taking proton from the benzoic acid and converting benzoate ion and benzyl alcohol. And this benzoate ion is adding with Na plus ion forming sodium benzoate. And this is the example, second example, and completion of this one. Detailed information is given, and detailed information of Cannizaro reaction by taking of two example, and one is the formaldehyde, second one is the benzaldehyde. These two molecules are involving in the Cannizaro reaction because of absence of alpha hydrogens. But here I am taking crossed Aldol, crossed Cannizaro reaction. Crossed Cannizaro reaction. Here crossed Cannizaro reaction is that only the Cannizaro reaction between two different aldehydes. Two different aldehydes is called as Cannizaro reaction. I am taking this one only. One is the benzaldehyde, other one is the formaldehyde. Benzaldehyde, formaldehyde. Here we have some doubt. One molecule is oxidizing and second molecule is the reducing by taking of same molecules. But we are taking two different molecules. What is the definition of crossed Cannizaro reaction? Cannizaro reaction between two different aldehydes. Two different aldehydes means already given that Cannizaro reaction is the self-oxidation and reduction reaction. One molecule is oxidizes, other molecule reduces అని చెప్పినాను. మరి in this case అండి, which one oxidizes, which one reduces? That can be decided by their reactivity అండి. According to mechanism అండి, step 1 is attack of nucleophile. A nucleophile is the NaOH అండి, concentrate NaOH. NaOH is giving Na plus and OH minus. Na plus and OH minus. Now OH minus is the nucleophile. Now there is a competition with the nucleophile. Formaldehyde first reacts or benzaldehyde first reacts. There is a competition. The competition is based on their reactivity. The reactivity of formaldehyde is much more than the benzaldehyde. That's why the formaldehyde first involved in the first step. This is the first one. Now OH minus attacks the end. This bond shifted to this side and OH minus is added to this one. And HO minus HOH. This one, step 1. Step 2 only, transfer of hydride ion. Transfer of hydride ion, H minus. Here, this is the transition or intermediate product only in the first step formed one only. Now it reacts with benzaldehyde. This is the benzaldehyde. CH double bond O. Okay. Now by shifting of this one only, so this one, the hydride ion is transferred. The hydride ion now added to this one. That's why the new product is this one. And here double bond O and OH plus benzene ring CH2 only, one hydrogen is added and O minus by shifting of here O minus. Now step 3 only, transfer of proton. H plus ion. Proton means H plus ion. Here HCOOH is the acid and this one is base only. Already I given explanation in Cannizaro reaction only. This hydrogen shifted to this side. That's why this becomes as a benzyl alcohol. And this becomes as a formate ion. This formate ion, when reacted with sodium plus and Na plus, became sodium formate. That's why this one benzyl alcohol plus sodium formate. So this is the crossed Cannizaro reaction. The Cannizaro reaction between two different aldehydes is called as crossed Cannizaro reaction. In this Cannizaro reaction, which one is oxidizes, which one is reduces, depends upon the reactivity. Highly reactive involved in the oxidation and low reactive involved in the reduction. This is very, very important one. Okay, thank you. Today class completed.